Artificial consciousness, AC, also known as machine consciousness, MC, or synthetic consciousness, Gamez 2008, Reggia 2013, is a field related to artificial intelligence and cognitive robotics, whose aim is to define that which would have to be synthesized were consciousness to be found in an engineered artifact. Aleksander 1995. Neuroscience hypothesizes that consciousness is generated by the interoperation of various parts of the brain, called the correlates of consciousness or NCC. Proponents of AC believe it is possible to construct machines, e.g., computer systems, that can emulate this NCC interoperation. Artificial consciousness can be viewed as an extension to artificial intelligence, assuming that the notion of intelligence in its commonly used sense is too narrow to include all aspects of consciousness. Philosophical views of artificial consciousness. As there are many designations of consciousness, there are many potential types of AC. In the philosophical literature, perhaps the most common taxonomy of consciousness is into access and phenomenal variants. Access consciousness concerns those aspects of experience that are amenable to a functional description, while phenomenal consciousness concerns those aspects of experience that seem to defy functional depiction, instead being characterized qualitatively in terms of raw feels what it is like. Orwellia, Block, 1997. Domenico Parisi, researcher at the Institute of Cognitive Science and Technologies, writes in his article Mental Robotics, that in order for robots to possess artificial consciousness, they must also have what he calls mental life. According to Parisi, mental life is to have internal representations of sensory input in the absence of the input. The debate over the plausibility of artificial consciousness. A view skeptical of AC is held by theorists, e.g., type identity theorists, who hold that consciousness can only be realized in particular physical systems because consciousness has properties that necessarily depend on physical constitution. Block, 1978, Bickel, 2003. In his article Artificial Consciousness, Utopia, or Real Possibility, Giorgio Budazzo says that despite our current technology's ability to simulate autonomy, working in a fully automated mode, the computers cannot exhibit creativity, emotions, or free will. A computer, like a washing machine, is a slave operated by its components. For other theorists, e.g., functionalists, who define mental states in terms of causal roles, any system that can instantiate the same pattern of causal roles, regardless of physical constitution, will instantiate the same mental states, including consciousness. Putnam, 1967. Chalmers' argument for artificial consciousness. One of the most explicit arguments for the plausibility of AC comes from David Chalmers. His proposal, found within his manuscript A Computational Foundation for the Study of Cognition, is roughly that computers perform computations, and the right kinds of computations are sufficient for the possession of a conscious mind. In outline, he defends his claim thus: computers perform computations. Computations can capture other systems' abstract causal organization. Mental properties are nothing over and above abstract causal organization. Therefore, computers running the right kind of computations will instantiate mental properties. The most controversial part of Chalmers' proposal is that mental properties are organizationally invariant, i.e., nothing over and above abstract causal organization. His rough argument for which is the following. Mental properties are of two kinds, psychological and phenomenological. Psychological properties, such as belief and perception, are those that are characterized by their causal role within an overall causal system. He adverts to the work of Armstrong, 1968, and Lewis, 1972, in claiming that systems with the same causal topology will share their psychological properties. Phenomenological properties, on the other hand, are not prima facie definable in terms of their causal roles. Establishing that phenomenological properties are amenable to individuation by causal role therefore requires argument. Chalmers provides his dancing qualia argument for this purpose. Chalmers begins by assuming that agents with identical causal organizations could have different experiences in virtue of having different material constitutions, silicon versus neurons, e.g. He then asks us to conceive of changing one agent into the other by the replacement of parts, neural parts replaced by silicon, say, while preserving its causal organization. X hypothesis. The experience of the agent under transformation would change as the parts were replaced, but there would be no change in causal topology, and therefore no means whereby the agent could notice the shift in experience. Critics of AC object that Chalmers begs the question in assuming that all mental properties are sufficiently captured by abstract causal organization. Ethics of artificial consciousness. If it were certain that a particular machine was conscious, its rights would be an ethical issue that would need to be assessed, e.g. what rights it would have under law. For example, a conscious computer that was owned and used as a tool or central computer of a building or large machine is a particular ambiguity. Should laws be made for such a case, consciousness would also require a legal definition, for example a machine's ability to experience pleasure or pain, known as sentience. Because artificial consciousness is still largely a theoretical subject, such ethics have not been discussed or developed to a great extent, though it has often been a theme in fiction, see below. 61. If, in any given year, a publicly available open-source entry entered by the University of Surrey or the Cambridge Centre wins the silver medal or the gold medal, then the medal and the cash award will be awarded to the body responsible for the development of that entry. If no such body can be identified, or if there is disagreement among two or more claimants, the medal and the cash award will be held in trust until such time as the entry may legally possess, either in the United States of America or in the venue of the contest, the cash award and gold medal in its own right. Consciousness in digital computers. There are various aspects of consciousness generally deemed necessary for a machine to be artificially conscious. A variety of functions in which consciousness plays a role were suggested by Bernard Bars 1988, and others. The functions of consciousness suggested by Bernard Bars are definition and context setting, adaptation, and learning, editing, flagging, and debugging, recruiting, and control, prioritizing, and access control, decision-making or executive function, analogy-forming function, metacognitive, and self-monitoring function, and auto-programming and self-maintenance function. Igor Aleksander suggested 12 principles for artificial consciousness, Aleksander 1995, and these are: the brain is a state machine, interneuron partitioning, conscious and unconscious states, perceptual learning, and memory, prediction, the awareness of self, representation of meaning, learning utterances, learning language, will, instinct, and emotion. The aim of AC is to define whether and how these and other aspects of consciousness can be synthesized in an engineered artifact such as a digital computer. This list is not exhaustive, there are many others not covered. Awareness. Awareness could be one required aspect, but there are many problems with the exact definition of awareness. The results of the experiments of neuroscanning on monkeys suggest that a process, not only a state or object, activates neurons. Awareness includes creating and testing alternative models of each process based on the information received through the senses, or imagined, and is also useful for making predictions. Such modeling needs a lot of flexibility. Creating such a model includes modeling of the physical world, modeling of one's own internal states and processes, and modeling of other conscious entities. There are at least 3 types of awareness: agency awareness, goal awareness, and sensory motor awareness, which may also be conscious or not. For example, in agency awareness you may be aware that you performed a certain action yesterday, but are not now conscious of it. In goal awareness you may be aware that you must search for a lost object, but are not now conscious of it. In sensory motor awareness, you may be aware that your hand is resting on an object, but are not now conscious of it. Because objects of awareness are often conscious, the distinction between awareness and consciousness is frequently blurred, or they are used as synonyms. Learning. Learning is also considered necessary for AC. By Bernard Baars, conscious experience is needed to represent and adapt to novel and significant events, Baars 1988. By Axel Clearmans and Luis Jimenez, learning is defined as a set of phylogenetically advanced adaptation processes that critically depend on and evolved sensitivity to subjective experience, so as to enable agents to afford flexible control over their actions in complex, unpredictable environments. Clearmans 2001. Anticipation. The ability to predict or anticipate foreseeable events is considered important for AC by Igor Aleksander. The emergentis multiple drafts principle proposed by Daniel Dennett in Consciousness Explained may be useful for prediction. It involves the evaluation and selection of the most appropriate draft to fit the current environment. Anticipation includes prediction of consequences of one's own proposed actions and prediction of consequences of probable actions by other entities. Relationships between real-world states are mirrored in the state structure of a conscious organism, enabling the organism to predict events. An artificially conscious machine should be able to anticipate events correctly in order to be ready to respond to them when they occur, or to take preemptive action to avert anticipated events. The implication here is that the machine needs flexible, real-time components that build spatial, dynamic, statistical, functional, and cause-effect models of the real world and predicted worlds, making it possible to demonstrate that it possesses artificial consciousness in the present and future, and not only in the past. In order to do this, a conscious machine should make coherent predictions and contingency plans, not only in worlds with fixed rules, like a chessboard, but also for novel environments that may change, to be executed only when appropriate to simulate and control the real world. Subjective experience. Subjective experiences or quailing are widely considered to be the hard problem of consciousness. Indeed, it is held to pose a challenge to physicalism, let alone computationalism. On the other hand, there are problems in other fields of science which limit that which we can observe, such as uncertainty principle in physics, which have not made the research in these fields of science impossible. Symbolic or hybrid proposals. Franklin's intelligent distribution agent. Stan Franklin, 1995-2003, defines an autonomous agent as possessing functional consciousness when it is capable of several of the functions of consciousness, as identified by Bernard Baars' global workspace theory, Baars 1988-1997. His brainchild IDA, Intelligent Distribution Agent, is a software implementation of GWT, which makes it functionally conscious by definition. IDA's task is to negotiate new assignments for sailors in the U.S. Navy after they end a tour of duty, by matching each individual's skills and preferences with the Navy's needs. IDA interacts with Navy databases and communicates with the sailors via natural language email dialogue, while obeying a large set of Navy policies. The IDA computational model was developed during 1996-2001 at Stan Franklin's Conscious Software Research Group at the University of Memphis. It consists of approximately 250,000 lines of Java code and almost completely consumes the resources of a 2001 high-end workstation. It relies heavily on correlates, which are special-purpose, relatively independent, mini-agents typically implemented as a small piece of code running as a separate thread. In IDA's top-down architecture, high-level cognitive functions are explicitly modeled. See Franklin 1995 and Franklin 2003 for details. While IDA is functionally conscious by definition, Franklin does not attribute phenomenal consciousness to his own conscious software agent, IDA, in spite of her mini-human-like behaviors. This in spite of watching several U.S. Navy detailers repeatedly nodding their heads saying, "Yes, that's how I do it," while watching IDA's internal and external actions as she performs her task. Ronson's cognitive architecture. Clarion. Clarion posits a two-level representation that explains the distinction between conscious and unconscious mental processes. Clarion has been successful in accounting for a variety of psychological data. A number of well-known skill learning tasks have been simulated using Clarion that span a spectrum ranging from simple reactive skills to complex cognitive skills. The tasks include serial reaction time, SRT, tasks, artificial grammar learning, AGL, tasks, process control, PC, tasks, the categorical inference, CI, task, the alphabetical arithmetic, AA, task, and the Tower of Hanoi, TOH, task, Sun 2002. Among them, SRT, AGL, and PC are typical implicit learning tasks, very much relevant to the issue of consciousness, as they operationalize the notion of consciousness in the context of psychological experiments. Ben Goertzel's OpenCog. Ben Goertzel is pursuing an embodied AGI through the open-source OpenCog project. Current code includes embodied virtual pets capable of learning simple English language commands, as well as integration with real-world robotics, being done at the Hong Kong Polytechnic University. Neural network proposals. Heikkönen's cognitive architecture. Pentti Heikkonen, 2003, considers classical rule-based computing inadequate for achieving AC. The brain is definitely not a computer. Thinking is not an execution of programmed strings of commands. The brain is not a numerical calculator either. We do not think by numbers. Rather than trying to achieve mind and consciousness by identifying and implementing their underlying computational rules, Heikkonen proposes a special cognitive architecture to reproduce the processes of perception, inner imagery, inner speech, pain, pleasure, emotions, and the cognitive functions behind these. This bottom-up architecture would produce higher-level functions by the power of the elementary processing units, the artificial neurons, without algorithms or programs. Heikkonen believes that, when implemented with sufficient complexity, this architecture will develop consciousness, which he considers to be a style and way of operation characterized by distributed signal representation, perception process, cross-modality reporting, and availability for retrospection. Heikkonen is not alone in this process view of consciousness, or the view that AC will spontaneously emerge in autonomous agents that have a suitable neuro-inspired architecture of complexity. These are shared by many, e.g. Freeman, 1999, and Cotterill, 2003. A low-complexity implementation of the architecture proposed by Heikkonen, 2003, was reportedly not capable of AC, but did exhibit emotions as expected. Sedone, 2009, for a comprehensive introduction to Heikkonen's cognitive architecture. An updated account of Heikkonen's architecture, along with a summary of his philosophical views, is given in Heikkonen, 2012. Shanahan's cognitive architecture. Marie Shanahan describes a cognitive architecture that combines Bars's idea of a global workspace with a mechanism for internal simulation, imagination. Shanahan, 2006. For discussions of Shanahan's architecture, see Gamez 2008 and Reggia 2013, and Chapter 20 of Heikkonen 2012. Takino's self-awareness research. Self-awareness in robots is being investigated by Junichi Takino at Reggia University in Japan. Takino is asserting that he has developed a robot capable of discriminating between a self-image in a mirror and any other having an identical image to it, and this claim has already been reviewed. Takino, Inaba, and Suzuki 2005. Takino asserts that he first contrived the computational module called a monad, which has a self-aware function, and he then constructed the artificial consciousness system by formulating the relationships between emotions, feelings, and reason by connecting the modules in a hierarchy. Igarashi, Takino 2007. Takino completed a mirror image cognition experiment using a robot equipped with a monad system. Takino proposed the self-body theory, stating that humans feel that their own mirror image is closer to themselves than an actual part of themselves. The most important point in developing artificial consciousness, or clarifying human consciousness, is the development of a function of self-awareness, and he claims that he has demonstrated physical and mathematical evidence for this in his thesis, to Keynote 2008. He also demonstrated that robots can study episodes in memory where the emotions were stimulated and use this experience to take predictive actions to prevent the recurrence of unpleasant emotions. Torigo, to Keynote 2009. Aleksander's Impossible Mind. Igor Aleksander, Emeritus Professor of Neural Systems Engineering at Imperial College, has extensively researched artificial neural networks and claims in his book Impossible Minds, My Neurons, My Consciousness, that the principles for creating a conscious machine already exist, but that it would take 40 years to train such a machine to understand language. Whether this is true remains to be demonstrated, and the basic principle stated in Impossible Minds, that the brain is a neural state machine, is open to doubt. Thaler's creativity machine paradigm. Stephen Thaler proposed a possible connection between consciousness and creativity in his 1994 patent, called Device, for the autonomous generation of useful information, in which computational critics govern the injection of synaptic noise and degradation into neural nets, so as to induce false memories or confabulations that may qualify as potential ideas or strategies. He recruits this neural architecture and methodology to account for the subjective feel of consciousness, claiming that similar noise-driven neural assemblies within the brain invent dubious significance to overall cortical activity. Thaler's theory and the resulting patents in machine consciousness were inspired by experiments in which he internally disrupted trained neural nets, so as to drive a succession of neural activation patterns that he likened to stream of consciousness. Testing for artificial consciousness. The most well-known method for testing machine intelligence is the Turing test. But when interpreted as only observational, this test contradicts the philosophy of science principles of theory dependence of observations. It also has been suggested that Alan Turing's recommendation of imitating not a human adult consciousness, but a human child consciousness, should be taken seriously. Other tests, such as Kohn-Skull, test the presence of features inspired by biological systems, or measure the cognitive development of artificial systems. Qualia, or phenomenological consciousness, is an inherently first-person phenomenon. Although various systems may display various signs of behavior correlated with functional consciousness, there is no conceivable way in which third-person tests can have access to first-person phenomenological features. Because of that, and because there is no empirical definition of consciousness, a test of presence of consciousness in AC may be impossible. Artificial consciousness in literature, movies, and television. Artificial intelligence in fiction. Von Monday in Arthur C. Clarke's The City and the Stars, an artificial being that was immensely powerful but entirely childlike. The Ship, the result of a large-scale AC experiment, in Frank Herbert's Destination, Void, and sequels, despite past edicts warning against making a machine in the image of a man's mind. Jane in Orson Scott Card Speaker, For the Dead, Xenocide, Children of the Mind, and Investment Counselor.